Hi guys, it's Mrs. Tucker. Let's do a little reviewing of multiplying mixed numbers by mixed numbers. And I want to use an area model. You guys should already have the model glued into your journal, so we can just add notes to it. So here we go. Here's my example. I want to take 3 2/5 and multiply it by 4 1/3. So I've got 3 wholes and another 2/5 of a whole, multiplied by 4 wholes and another third of a whole. Okay, so I'm going to start off with a grid like this. And first I want to model, you guys have put together multiplication tables. Well, this is kind of like a big multiplication table with lots of details in it. I first want to model 3 wholes and another 2/5 of a whole. So let's call this whole bar right here, the whole yellow bar, 1 bar, 1 whole. The blue bar is 2 wholes. Now I've got 3 wholes. See this 4th hole right here? I need to bust it up into 5 equal pieces because I only want 2 of those. So if I bust it up into 5 equal pieces and only shade 2 of those pieces, now I've got 1/5 here and 2/5 here. So what I've got shaded in right now vertically represents 3 2/5. Now, we're going to go this way horizontally to represent multiplication by 4 1/3. So I've got 1 bar here, 1 whole bar going this way. Here's my 2nd bar going horizontally, my 3rd bar going horizontally, my 4th bar going horizontally, and I need another third of a whole bar. So let's bust this last bar up into thirds. 1/3, 2/3, 3/3. And I colored in the third that I want. So you guys should do the same. And if you had 2 different colors, that'd be great. Color in your 2/5 here. Highlighters work great. Highlight this way a different color. And if you don't have different colors, that's okay. Use the same color. All right. So now the area that I'm talking about, that I'm interested in, is the area where these all overlap, this overlapping region here, right here. Okay? So let's count and see what we've got. Let's put all of our wholes together. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So let's write that down. I've got 12 holes in the center right here. Okay, now over here, all of my holes have been busted up into fifths. So let's count and see how many fifths we have. Here's 1/5. Here's another 1/5. 1/5. 1/5. 1/5. Here's another 1/5. Here's a 1/5. And here's a 1/5. All right, so here we go. I'm going to count them up. I've got, I was trying to get a highlighter. Here's 1/5, 2/5, 3/5, 4/5, 5/5. And you guys know 5/5 is the same as what? An additional whole. Yeah, that right there makes a whole. So let's add another whole. And how many fifths do I have here? Let's add on another 3/5. All right? Okay, so let me grab my highlighter. Down here, let's look at our thirds. I've got, let's write this in. I've got 1/3 here, 1/3 here, and 1/3 here. So if I take a third plus another third plus another third, is that not 3/3? Yeah, I've got 3/3 there, which makes what? Yeah, another whole. So let's add on another whole there. Now down here at the bottom, I've got 1, 2, this whole box right here represents a whole, but it's been changed into how many total little pieces? 1, 2, 3, 4, 5. I've got 3 rows of 5 in each row. That's 15 pieces. 15 15ths makes that whole. But I have only shaded in how many 15ths? 1, 2. So I have to add on another 2/15. All right? So I can take 12 plus that 1 plus that 1, and I've got 14 wholes. I need to take my 3/5 here and add on 2/15 to that. And I know you guys know that you can't add unless you've got common denominators. So I'm going to change 3/5 into an equivalent fraction that's been busted up into 15 pieces. So 5 times 3 is 15. If I take the numerator and multiply by 3, I get 9. Add that to 2/15, and my final answer, what's 9/15 plus 2/15? That's 11/15. Okay? Now, that's one way to multiply mixed numbers. That's the long way, and you don't always want to be drawing these pictures. So let me show you another way. Okay, here's my original model. And I scooted it up a little bit so we could see the bottom was being cut off. So let's go back. Let's get our 1, 2, 3 holes and 2/5 here. And then horizontally 1, 2, 3, 4 holes and a third here. What we originally were talking about. Okay? What I could do is bust these fractions up into the same size pieces, knowing that a whole is 15/15. See this down here? See this section right here? The overlap of those two fractional pieces actually creates that common denominator we saw in the last slide, our 15/15. So what we could do is take all of these pieces and break them up to the same size, break them up into 15ths. We could do the same thing down here and break those up into 15ths. And then count how many 15ths we've got down the side here. There's 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 26 up to this point, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41. I have 41 15ths. All right, write that down. 41 15ths just down along the side here. Plus, how many 15ths in the center? If each one of these guys represents 15 15ths, I want you to tell me how many 15ths are represented by those 12 squares. I'll pause the video. Have you got figured out how many 15ths are in the center here? Did you come up with 180 15ths in the center here? Let me show you what that looks like. Whoa, there we go. Here's 15 and here's 15 and here's 15, 15, 15, 15, 15, 15. I've got 12 boxes with 15 pieces in it. So those holes, I've got 12 groups of 15, which means 12 times 15, which is 180. And these pieces down the side here, yeah, I've got 180 15ths. The pieces down the side, I have 41 more 15ths. So altogether, I have 180 15ths in the center, plus the 41 18ths that are shaded in purple, for a grand total of 221 15ths. 221 15ths, well, how many holes is that? Well, you're going to write that as a fraction. 200, whoops, let me back that up. That got a little ahead of me. 221 15ths means 221 divided by 15. Which one goes in the house? Yeah, 221 goes in the house, 15 goes outside. Let's do the long division. I like to do columns and keep everything straight. 15 goes into 22 once. 15 times 1 is 15. 22 subtract 15 is 7. Bring down your 1. How many times does 15 go into 71? It goes in there 4 times. 4 times 15 is 60. 71 subtract 60 is 11. So my final answer is 14 wholes and another how many 15ths? I'm going to leave my answer, my remainder, in fraction form. 15 goes into 221, 14 whole times, and another 11 15ths of a whole. And that's my final answer. And that's what we got before. So here is your shortcut if you don't always want to make the model. And we don't. It takes too long. What you're going to do is you're going to change each one of these mixed numbers to an improper fraction. So 3 and 2/5, take the 5 times the 3 plus the 2. That's 15 plus 2 more is 17/5. Let's take the 3 times the 4, which is 12, plus 1 more is 13. That's 13/3. How do you multiply these two fractions together? Tops times tops, bottoms times bottoms, multiply them straight across. Go ahead and multiply these out, and you get 21 over 15. 221 over 15. Isn't that what we got earlier? Yeah, 221 15ths. And then you go ahead and do the long division, and you get that for your answer. Okay? This method right here is your shortcut. Change your mixed numbers to improper fractions, multiply your numerators together, multiply your denominators together, do the long division here, and change it back to a mixed number. All right? That's all there is to it. Good luck with that, guys.